scratching your head as to why a vehicle is returned to the workshop with a repeat discharge battery. Check the charging system and everything looks okay. The problem might be parasitic draw. Parasitic drain or draw is a term we use to describe an unwanted load or current on a vehicle's electrical system. This usually occurs when the vehicle ignition is switched off. The end result, whether it takes a few days or happens overnight, is a flat battery and a car that won't start. When testing, if we have established that the battery and charging system are functioning correctly, we need to determine if the fault is caused by parasitic draw. If the vehicle has a proximity entry system, ask the customer where they keep the vehicle entry key or fob. If the fob is kept within range of the vehicle, the entry module will not go to sleep when parked, causing excess current draw. Before we pick up a meter or scan tool, switch the ignition off, move the key away from the vehicle, close all doors and spend a few minutes performing a visual inspection for any device still operating that may draw unwanted current. Are any interior lights still on? Don't forget to check the vanity, glove box, luggage and engine compartment. Have the radio or media devices turned off with the ignition? Or are there any accessories plugged into power outlets that may be causing the battery to drain? If we're confident there's no obvious reasons, we can begin circuit testing. Now there's quite a few ways to do this, so today we'll only look at the most effective. Some new model vehicles support battery management diagnostics. A quality scan tool or OEM API can access this information and supply a report that will tell us which modules are drawing excess current when they shouldn't be. This will make the diagnostic path a little easier to follow. If the vehicle doesn't support this function, we can use some tools we all have in the workshop. Most new vehicle control modules stay active for a predetermined time once the ignition is switched off and the doors are locked. This may range from 5 to 30 minutes, so it's worth grabbing the vehicle repair manual to confirm. Later in our diagnosis, we may need to access the vehicle interior fuse box. So it's a good idea to leave the doors open, but trip the latch in each door so the body computer is fooled. Don't forget to disable the interior light or light switch. With the bonnet open, ignition off, and all door latches closed and locked, attach 1 metre lead to the battery negative post and 1 to the negative terminal. Place the red lead in the amp meter port with the highest value, in our case 20 amps, and turn the meter to 20 amps DC. Next, carefully remove the negative terminal from the battery post and place to one side. As you can see, our meter is completing the vehicle ground circuit, so any current flow from the battery must travel through our tool. Now, this is where it pays to have some knowledge of the vehicle you're working on. An older car with a basic engine management system and radio will draw around 20 to 30 milliamps for module keep alive memory. A modern high-end vehicle with multiple control modules, passive entry and complex media system may draw closer to 100 milliamps for keep alive memory and vehicle entry transmitter and receivers. But as always, refer to the manufacturer's specification for the correct key-off current draw values. An easier way to determine if the vehicle has parasitic draw is to follow all the procedures from before, except we don't need to disconnect the battery terminal. There are numerous different types of low amp clamp available, and their price generally reflects their accuracy, so keep this in mind when using one of these. We can use a multiplying coil if needed, but this can be time-consuming to set up and requires us to read our meter result and multiply it by the number of coils in the loop. Also, be careful of any low amp clamp that requires us to convert a millivolt reading to milliamps. If not done correctly, we can make a poor diagnostic decision. Probably the most effective current clamp to use is one that connects to a lab scope, as these can be viewed easily and accurately. Remember to zero the clamp before attaching it to the vehicle and noting the value. We can see there's an excessive current draw in this vehicle, so there's a couple of ways we can pursue the fault from here. If the fault is occurring on a new vehicle, I strongly suggest checking any technical service bulletins for that model that relate to parasitic draw. It may be a case of one control module not sleeping and may require a reprogram to rectify the fault. For other vehicles, there are a couple of ways to localise the search. Removing fuses one at a time to isolate the circuit works well on simple electronic systems or older model vehicles. This is one of the reasons for leaving the doors open and latches tripped. If we cycled the key or door locks to gain vehicle entry and we're using a series connected meter, the current draw would be excessive, causing its fuse to open or result in irreparable damage. This test method is reasonably accurate. Just watch the meter screen while each fuse is removed. We need to leave each fuse out of the vehicle in their correct order, as some systems use a voltage supply from 2 circuits to operate. When the meter value drops to an acceptable level, we have identified the circuit at fault. Open the corresponding circuit diagram and look for all components or shared systems that may be the cause of the parasitic drain. Reinsert the fuse and disconnect any component on that circuit one at a time while watching the meter. When the current value drops to an acceptable level, we have located the fault. So why can't we use this method on a newer type car? Well, the simple answer is that removing or replacing a fuse on a newer vehicle may remove power from a module, resetting it, thereby masking a fault if it's intermittent. Also, the removal and replacement of a module fuse may wake up the rest of the network, meaning we need to wait for another given period of time, letting modules power down, before recommencing our diagnosis. Interrupting the supply voltage to modules may require us to perform lengthy relearn procedures on each module, increasing the cost to the customer. The best way to check these circuits is to perform a voltage drop test on each fuse. When we normally perform this test, any voltage that cannot flow through the fuse will be displayed on the meter. So if the fuse was open, we would see 12 volts displayed. A serviceable fuse will allow current to flow in a circuit, causing a small resistance, and this resistance will cause voltage drop. With this in mind, we can treat our fuse as a resistor, and although small, we can measure the voltage drop across it. We can now determine which circuit is the cause of the parasitic drain by watching the meter display as we move from fuse to fuse. Make sure there is a good connection from the meter probes and the fuse, and wait for the reading to stabilise before making a judgment call. J-case fuses are a little harder to measure as they require the plastic cover to be removed first. If we test all the fuse circuits and cannot find the current draw, we need to check circuits that are protected by fusible links or in-harness slow burn fuses. These are generally found in the starting and charging cables. Customers expect the very best from the technician that they've entrusted to fix their car. So, prove to them and yourself that they've made the right decision by learning as much as you can. Thanks for watching.